All right, now we're going to do tangent and reciprocal. So just a couple examples here. Now remember, when we're graphing these, well, except for really tangent and cotangent, when we're graphing secant and cosecant, we're going to dot in sine and cosine first with the transformations given. So this is good review for what goes on with sine and cosine. Let's go ahead and fill in our details. The negative out front is going to make a reflection over the x-axis. And since we're working with secant here, I'm going to start with cosine. So cosine reflected is going to start at a minimum and go to minimum, max, and then back in one period. We have a 2 out front as well, so that's going to be our that's going to be the amplitude of the cosine function. And it's going to be the distance between the curves for secant. The 2 in front is going to affect the x is going to affect the period of the function. We're going to do 2 pi divided by 2 to get pi as the period of our function. So minimum to minimum is going to happen in pi units. And we have no phase shift here because we don't have anything after that x in the parentheses. And our vertical displacement, we're down 1. I'm going to go ahead and dot in the vertical displacement here, dot in that midline. I think it's really helpful to have that extra sketch of what cosine's going to look like. So I'm going minimum to minimum in pi units, and I'm going from the midline 2 down and up. So since my midline's at -1, I'm going to start at -3, and one period of the function is going to end at -3, so it's going to happen at pi. In between, which is going to be pi over 2, which you can label or you don't have to, we're going to go up 2 from that midline, so that point is actually pi over 2, 1. And right in between our min and max, we're going to cross the midline. So remember, you're just breaking this into fourths. So that's one period of our cosine curve. I'm going to go ahead and finish out over 2, up 2, over 2, down 2, down 2, over 2. Oops. Again, make sure everything is equidistant here. And this way. So there's our cosine curve. Now, to make our secant graph, we need a couple more things. We need asymptotes, and our asymptotes happen where our cosine graph crosses the midline. Sorry about the bell there. Okay, so our asymptotes go through where our graph crosses the midline. That one was not straight up. All right, and our curves go in the opposite direction of our cosine curve. So they're going to meet up. And you don't have to plot points, but they need to be nice. If you needed points, I would let you use your calculator if you needed those points in between. Okay, the last thing we need to do is deal with domain and range. Range is easier. You just have to exclude where your cosine curve lives. So cosine is between -3 and 1. So the range here is from -infinity to -3, including -3, because we have those places where our curves meet up. And the max of our cosine would be at 1, so from 1 to infinity. Our domain's a little more tricky. We need to exclude where our asymptotes are. So I like to label the asymptotes first, and this one is a little funky. So if pi is 8, I think spaces out, 1, 2, 3, 4, 5, 6, 7, 8. That means that every 2, so this guy here is pi over 4. This would be pi over 2, so this would be 3 pi over 4. Pi is 4 pi over 4, so the next fourth would be 5 pi over 4. And then the next fourth where my asymptote is 7 pi over 4. So here, as we're looking at this, the way we write our domain is to start all reals. X cannot equal. We're going to use this first positive asymptote, pi over 4, n, and then we're going to define what that n is. And here, if you look at the pattern of the numerators, 1 pi, 3 pi, 5 pi, 7 pi, pi over 4 n, where n is an odd integer. So you're going to write that little equation and then describe what those numbers are. And here, since it's 1, 3, 5, 7, they are all odds. All right, that's a secant graph for you.